Welcome to BKSS Academy. I hope you are doing great. Now we will discuss about pipelining in computer architecture. This topic will be helpful for your different kinds of examinations as well as for enhancing your knowledge. It is a process of arrangement of hardware of CPU such that overall performance will be increased. One task at a stage, same time, other task will be processed at a different stage. That means a CPU will be converted into different stages. So different stage will handle different task. Simultaneously execution more than instructions will takes place in pipeline processor. It is the definition of the pipeline where simultaneously multiple instruction will be processed. In pipelining, multiple instruction overlapped in execution. So in pipelining, multiple process will be executed. One diagram is here, that is input stage 1, that is the interface register latch. Stage 2, this is also latch. Stage 3, this is latch. Stage 4, then output. That means in between each stage in the CPU there will be interface register, that is called as latch. So we can consider this from this graphical diagram, that is clock cycle 1 stage 1, clock cycle 2 stage 2, clock cycle 3 stage 3. So 3 instructions can be executed. Here the number of phases, that is in an CPU, that is instruction phase, instruction decode, instruction execution, memory, write back. These are the 5 stages in the CPU. One example is given here. For so this is the diagram, and for non-pipeline, one clock cycle is used for one stage. This is one stage, and 5 clock cycles used for 5 stages for one instruction. So for one instruction, it will take one clock cycle for each stage. Suppose this is the CPU having this number of stages. So when if instruction is going for execution, it will start executing here one clock cycle, this is 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 one clock cycle, then output will be provided. So 5 clock cycle it will take. If there is 8 instructions, so 8 into 5, the 40 clock cycles are required for processing of 8 instructions. In case of pipelining architecture, that is a for pipelining architecture we need space state diagram. This is the space state diagram. So clock cycle 1, instruction 1 come for the stage 1. In clock cycle 2, instruction 1 will transfer to the instruction 2 will go for, this is the clock cycle 1 instruction phase. Then instruction 1 will go for second phase, that is instruction decode. In between that, instruction 2 will be fetched. Similarly, when instruction 1 is executed, instruction 2 is decoded, and in between that instruction 3 can be allowed into the instruction phase. Similarly, this process will go on. So all 8 instructions will be completed with 12 cycles, 12 clock cycles. Whereas in pipelining CPU, it was taking 40 clock cycles. The number of stage is equal to k, number of instruction is n, so total number of clock cycle will be k plus n minus 1. This is the formula, k plus n minus 1. As the above diagram tells, k is equal to 5, n is equal to 8. So 5 plus 8 minus 1 is equal to 12, which is shown here. When CPI clock per instruction is equal to 1, suppose 1000 instructions are there, total clock cycle is 5 plus 1000 minus 1, that is 1004. Total clock cycle is required for processing 1000 instruction in pipelining processor. CPI will be equal to total clock cycle divided by total number of instruction, that is 1004 divided by 1000 is less than equal to or similar to 1. Speed up is equal to non-pipeline clock cycle divided by pipeline clock cycle. So non-pipeline clock cycle is equal to 40 when we are taking 8 instructions, and pipeline CPU is taking 12. So 12 by 40, it will be 3 point something. Similarly, efficiency can be calculated from the space time diagram. Total box is equal to 12 into 5, 60. Use box is 40. So use box is 40 and total box is 60. So efficiency will be calculated from the space time diagram, that is use box by total box. 40 by 60 is equal to 2 by 3. Thank you.